All right. Hello, I'm Alex with Prelude, and today I'm going to be talking to you a little bit about Operator version 0913 and one or two of the features that we've pushed in with this release, specifically beacon protocol hot swapping and TTP similarity checks. So to kick this off, first thing I'm going to do is drop into my NUMA directory. NUMA is our default agent. You can get it off GitHub. I'll provide links to this video below. But what I'm going to do is rebuild the agent using the provided build script, and then go into my payloads directory. So we're going to be running all of this off localhost, but all of the concepts presented are going to apply if you're going through a redirector or if you're going from a VM to host or VM to VM, depending how you've set up your configuration. I'm going to go ahead and run the NUMA Darwin agent and give it a name. I'll just name it demo, and then I'll hit enter. By default, the NUMA agent's going to beacon over TCP raw using port 2323, which is our default listener for TCP. And if I go into settings, that's where I could actually find out that port. But what I really want to check is what my exposed IP is. By default, we make this localhost with new installs so that you explicitly have to share all interfaces. So I've already set it to quad 0 for all interfaces, but that's something to check when you're actually using Operator. Now I'm going to jump over to the emulate section and go to the red range. Again, by default, agents are going to beacon into the red range. Ranges are just a way for you to cluster implants agents all together. You could have Mac, Windows, Linux agents all in the same range. It's just a way for you to logically group them together to deploy adversaries against. I can see my demo agent has beaconed in over TCP. If I go to this triple up chevron over here and click open, you'll see the new update configuration modal. All of the fields here are updatable and will actually send a task to the agent to update its in-memory running configuration. So we could have it change that range to any other arbitrary string we want. We could actually have it change the AES key that it is using to encrypt commands, encrypt and decrypt commands, I should say, that are being sent between the command and control server and it. We can also, as I described, update the contact method. So NUMA itself supports raw TCP and raw UDP, HTTP and gRPC out of the box, and you can task the agent to update to any of those protocols. So what I'm going to do is tell NUMA to update to gRPC, and I'm going to give it a sleep interval of 5. By default, it's 60. We don't want to be waiting a minute for every beacon, but I'll set it to 5 so it'll go a little bit faster. Then I'll click update. So you'll see a couple things happen. The first thing you'll see is that a new link has been generated for that agent, and it has gone green, which means the agent collected and executed that link successfully. So links are our way of describing the actual discrete TTP, the lowest level link in an attack chain, and then chains a bunch of links altogether constitute an adversarial kill chain. Wow, that was a mouthful. So if we click here, we can see a couple things. First, we use the keyword executor, which I've done a couple write-ups about if you want more details on what that means. And then the keyword that it was tasked with is config, and then a JSON blob. So what actually happens is the agent will grab that JSON blob, unmarshal it, and then apply those fields to the agent's in-memory running configuration, and then gracefully tear down its existing C2 channel and stand up a new C2 channel. If we take a look over here, we can see that's actually what happened. So the agent was connected via raw TCP, grabbed that link, and then it went ahead and refreshed the C2 and then started beaconing in over the new protocol that we told it to beacon in over gRPC. So this is great if we want to tell the agent to, for example, change its AES key and then update to HTTP, for example. and then I can just tell the agent to do that, and then we'll have a successful task sent to the agent telling it to do exactly that. Well, clearly we have a small UI wrapping issue here, but that's pretty easy to fix. This is great for discrete actions, me telling the agent to update, but manually is not really the purpose of Operator, and what we want you to be able to do is actually task an agent as part of an overall engagement. So what I'm going to do is jump over to our TTP Editor section, and I'm going to create a new TTP. I'm going to give it a tactic, command and control, and then a technique. We'll give it application layer protocol. It's not exactly a perfect name for it, but that's fine. Then I'm going to give it a name, and this will be update the NUMA configuration during engagement. So I'm just filling out the metadata fields associated with this TTP. And now I'm going to actually configure the meat of the command, if you want to put it that way. I'm going to select a platform. I'm only really worried about Darwin, which is Mac platforms right now, but you could apply the same concept to Linux and Windows, and literally the exact same TTP I might add. And we're going to give it a keyword executor. We won't get any nice, pretty syntax highlighting here because keyword is our own made-up internal language. So what I want to do is change during my operation from HTTP to TCP and tell the agent to grab a new address, which will be our server address, but on that new port, and then I will click save. I'm going to save that TTP, and now this is available for use in an adversary profile and something we could use during an actual operation. One cool thing that we did add with this release is similar TTPs. So we actually do keyword distance analysis on these commands. So if you have multiple similar TTPs, we can actually tell you that we think they're very similar, and it'll help you with consolidation when you get into the hundreds and thousands of TTPs in your operator instance. So as you can see, we have another one called update NUMA's running configuration during an operation. That's very similar to the one we made right now, but this one will go from whatever to HTTP. But we want this to stay TCP for this particular use case, so let's go ahead and use that one. I'm going to jump back into the emulate section, over to my red range, and I'm going to create a new adversary. This will be demonstration. And then I will add TTPs. So first thing I'm going to do is look for that update configuration. This is actually the last update that we sent to our agent. This gets stored as what we call an ephemeral TTP. Not important, but it is available for you, and you can view the actual task that got sent. The one we want to use is this one, which is our update the NUMA configuration during an engagement. So I'm going to add that TTP to this adversary. Let's also add in just some discovery. Let's do like process discovery or something simple just for demo purposes. PSAUX sounds good. And maybe a who am I? Do we have that? No. We have a who though. No. All right, I need to add that. Let's do this instead. So up here we have what are called tags. Tags are TTPs that we've combined into a light profile of sometimes a threat actor or just an overall objective. So as you can see, we have a Fin6 profile / tag. We have a ransomware tag, and then we have ones that are destructive that you can encrypt things on disk and whatnot. The one I'm going to look at is Crown Jewels. So inside Crown Jewels, I'm going to add some general discovery stuff. So like this one, find recent files. This will grab everything that was updated within, modified, I should say, within the last 24 hours. Then we could add some Windows TTPs to this adversary, but because we're not really worried about Windows, we won't do that. So now what we're going to do is take a look. We have our demonstration. We've got our adversary with 3 TTPs attached, one of which will actually update us from HTTP to TCP during the operation. Now I just deploy the adversary against that range. So next beacon will come in. The agent's going to grab and execute that command, and we can see that's exactly what happened. Then the agent's going to continue to run its tasks until it runs out of tasks to execute. So let's take a look. We finished running our entire profile, and we can see that the agent updated its configuration from HTTP to TCP, and we can see that happened over here. C2 was refreshed, and then it ran the following 2 instructions. And those following 2 instructions were PSAUX, which grabbed our system processes, and then you can see the facts that were learned from that particular task. And we also found recent files, which, a couple screen recordings of stuff that I've been working on, along with, DS stores and whatnot, and the So Simple 1 box. One of the cool things about our system also is that we can actually say, after we've learned this knowledge, here are potential TTPs that could be used after executing this particular TTP. So because we just found recent files and we've learned a bunch of file facts as well as a directory fact, we can say that we might be able to stage collected files, and we might be able to encrypt those files in place, or we could, exfiltrate those artifacts. So that really, in a nutshell, is beacon protocol hot swapping. Again, you can do it either manually, or you can go ahead and add that to an adversary so that you could, during an operation, actually change your beacon's protocol to a new protocol. It increases the type of emulation capabilities that you have, and also makes it a little bit harder for Blue Team to just, fingerprint HTTP beacons or fingerprint your TCP beacons. Thanks for watching, and I hope you learned something.